Good morning. So Ken has a couple of exercises you guys can actually see where it's good practice because the assignment, it's not that he's going to ask you the exact same things because the data sets are obviously going to vary from, um, data set to data set. But the good thing about these particular exercises is that it kind of, coaches your intuition, especially as it pertains to things like what is an appropriate display plot to make? What's an appropriate summary? What can you glean about the characteristics of your distribution? And even asking things like, what can you tell about the characteristics of your distribution might have some implications in terms of kind of what statistical inference you can actually do. Because if you guys remember from second year statistics, you can't actually perform any inference on samples that don't look symmetric, right? So there are things we check when we're going through our data analysis that informs our next course of action. So that's what we're going to be looking at. So actually, there are tons of examples on his website. I just pulled out just a couple. Anyways, they'll probably take a bit of time because you can see that the assignments are pretty involved and I haven't gone through it. Well, I mean, I've done them before in the past, but I'm going to do them in real time, right? It's just easier to kind of do it along with other people. Now, remember that you're creating graphs, and I don't know if he's posted assignment 1. You guys can let me know in the chat. But if he has posted assignment 1, of course, you guys know that the whole course is designed under tidyverse. So ggplot is while you're making graphs or whatnot, this is embedded in, right, in tidyverse. Cool. Oh, you cannot view it yet. Interesting. Okay, so that's probably gonna, I think the way it was set up last winter was that people had 48 hours to do it. Once it opened, and I think everyone had the same, it opened up for everyone at the same time. So that's probably why it will probably open up in the middle of this week. Okay, so remember the first thing to do, guys, whenever you load your assignments, and this is not just the ease of your own reading your own reports, but also, because okay, cool. So it'll open tonight. So this is not just for the ease of your own reports guide, it's also for certain, right, for cosmetic reasons, in the sense that, like, when a TA is grading your work, it's important that things read as, grammatical, well presented, formatted, and those are little things that, right, the add in terms of points. So remember to make sure you always have message equals false, warning equals false. Now, these are doing opposite things. I mean, they're doing related, but not the same things. Message equals false is actually preventing the loading, because you see that when you run tidyverse, it will actually open up every single package, and that's tedious, right? So to prevent the package from loading, I just literally put message equals false and warning equals false. This is because when you knit your actual PDF to HTML, which you probably will do when you download or when you submit your assignments, you wouldn't want that part showing. You see how it loads these chunks here, and it does. It was actually loading as it was going. You see how eventually it loads like tidyverse. So I go back up very, very far up. It's like doing this, right? So you don't want this to come up in your assignment, this part where it's attaching packages. And you also don't want the warning message of it saying that ggplot was built under version 4. Those kind of things you don't want. So you kind of put message equals false, stop this attaching a package, and warning equals false. It doesn't tell you how, which version ggplot was built under. Okay, so anyways, he has a bunch of data sets. Some of them I think he probably made himself. This one I'm looking at is under his website. It's called exercise. So if I just kind of pull it up, you will see that it's a data frame that is separated by space rather than tabs. That certainly matters in terms of, right, the delimiter. Because when you want to, remember, read _ delimiter, guys, this is inside of the tidyverse package. It's in readr, right? It's here. And when you put one space, you're saying it's separated by a space. If it's separated by a tab, it's different, right? And it actually matters, right? What you put in after the URL, because if you put in a space or a tab, whatever, the way in which your data set loads looks different, right? So make sure you guys are always checking before you actually open the package. And I'm gonna actually, oh, I thought I disabled the waiting room. You're gonna see that you should always check what your data frame looks like before you actually load it. So it's loading it properly, right? Okay, anyways, so now let's see what we got here. Basically, remember, always attach your variables. That's to avoid having to do some things like the following. Like you see now, I know that, let's say exercise. If I look at, glimpse of exercise, I know that obviously there's only 2 columns. It's a small data set, but I don't have to do $, right? So I know that there's gender, and I think there's also, let me see. So I had exercise. Yeah, so there's minutes, and I think there's gender. So you might ask yourself, like, is there a different amount of time that they spent exercising for the genders? What this data set's asking. Maybe there's a speculation that I think one particular gender exercises more than others. If this data set was actually complete, you'd imagine they would actually include variables such as the type of exercise you're doing, whether or not it's cardio or weightlifting, etc., and aerobic, etc. If they want to be very complete. But anyways, you can see that I don't have to do things like the following, exercise, $, gender, merely because I've already attached my variable. So if I just say gender, it will just load, right? So these are little things to remember. Anyway, so it's kind of there. Now, if you want to display some of your data, and he can always ask this, right? So I'm going to almost assume as if we're doing an assignment basis. So homework, it's part A, basically, let's call it A. He does always ask things like, read in your data and display things. So attach, Michael, actually, so it attaches your variables to the global environment, right? So because if, for instance, let's suppose I do the following. If I detach the exercise variable, right? Then next time I actually ask for gender, you see it doesn't, you see it can't read it. I see how it doesn't pick up the variables. I have to actually then do the following. Exercise, $, gender, right, to pull it up. Whereas if I attach the variables, right, then it just allows me to kind of, I can work with them without having to actually attach it every time I want to actually work with the variable, right? So when you don't attach, you have to call the variable every single time. So attaching it kind of saves you a bit of time, so you don't have to call the variable every time you want to work with it, basically. Yeah. So, but this is a good point, Michael, by the way, because if you don't want to use variable anymore, you don't want to have 2 variables with the same label, detach your data set. You no longer want to use the detach function so that you remove data that you don't want anymore from your global environment, right? So this does bring a good point to note that if you no longer want to use a data set, then detach it, right? To avoid having overriding of your variables, basically. Tibble is actually something that's in tidyverse, right? So Tibble is in tidyverse, so it kind of functions similarly to, data.frame. Like when you want to take single variables and you want to create a data frame, basically, right? A Tibble just creates a data frame, basically, but it's doing it using the tidyverse thing. You can, Eddie, but the problem is that when your coding gets more and more difficult, if you have a large data set, you can imagine you don't want to have to keep calling your variables every time. You don't want to, you can do that, but you don't want to keep calling your variables every time you want to use them. That's why you attach. But yes, you can, because the $sign does draw it up. But Tibble, just to be clear, guys, works similarly to data.frame, but it's within tidyverse, right? So it does actually take 2 vectors and create like data frames, basically, right? So for instance, as an example, so just because somebody asked about Tibble, I'll just say, as an aside, right? Let's see what Tibble does. Tibble in tidyverse, right? So you actually can't use this unless you load tidyverse. So you'll actually see that. Oh, I'm going to post it on my GitHub afterwards. I actually don't have it. I'll post on my GitHub afterwards. I always post it here. So At the end of the lecture, I'll post it in my GitHub. I also post the YouTube video on my YouTube page, right? So yeah, I'll post it here, and I also posted YouTube on my YouTube page, but you can actually find my YouTube page in the discussion board. I posted that there too. But yeah, so I'll post at the end of the class as people like to look at that. Yeah, but Tibble, you can see that. Let's suppose I created something called X. Let's call it a list of 1 to 6. Y, let's call Y to be equal to a vector 1, 2, 4, 6, 8, 10, 12, right? So the length of both of them are equal, right? So you can see that the length of both X and Y are the same. That's important because you can't use Tibble if they're not. Now, if I want to create a data frame, so call it dat, I might use Tibble of X, Y. You can see that what it would do is it would create a data frame. So now if you look at if you preview what your thing is, you can see that what you get is a data frame. So you can see that it actually does something similar to data.frame, except it's with a tidyr. So that's what that is. Okay, so is that clear? So if somebody asked what Tibble is, so that's what Tibble is. It takes 2 vectors. So, long story short, it takes 2 vectors, right? And it actually creates a data frame. It could take 2 more vectors, by the way. It takes, a collection of vectors and creates a data frame, right? In the environment, in the global environment. So that's what it's doing basically. C is just a vector. So C is just a vector, right? We can actually check. I think they're rather similar. There's a subtle difference. But let me just have a look and see. STAC33. I don't want to waste too much time on this. This is not really very important. And I kind of want to choose something else for the homework, but let me just double check and see. I think there might be a subtle difference in terms of let me see. Sorry, I don't know why I called it tab3, but whatever. We can see that in the first one here, you get kind of like a table. The second one, you get kind of like a data frame. So they're kind of similar, but Tibble gives you a table, whereas data frame and base R gives you a table. It's like it's kind of a different object. Most of the time, it doesn't have a real big difference. Data.frame and Tibble doesn't necessarily have a big difference, but sometimes when you want to work with tables, it does. So the real difference, most of the time, you won't notice the difference between Tibble and data frame. But there are some moments where you want to use tables to do certain operations where Tibble and data frame have different meanings, basically. So long story short, for the most part, it doesn't have a big difference. But you're right, except when you want to work with tables, which may come up later on, you'll notice that construction of a table might be a bit slightly different in terms of the object, right? So working with tables, you might find Tibble to be a bit more helpful than data.frame, right? Because Tibble is not quite a data frame, but it operates in the same way under most circumstances. But when you want tables, you might want to use Tibble instead. But they kind of work in a similar kind of way. But you can see that it's slightly different objects, basically, right? You can see that they're not quite the same object if you look at them, right? Okay. So yeah, I should really say a table, right? In the global environment, just because there's a subtle difference, but most of the time you won't notice it. If you're just building data frames, you wouldn't notice most of the time. Okay, so now let's look at some stuff you might see in. So Ken always asks he always starts by saying display some of your data. So there's a couple of things you could do in base R, and we really should be trying to use tidyverse basically, right? So I'm not going to show you because you guys know you use head to of your data to preview your in base R, right? So in base R, you would use the head function. Is everyone aware of this? So head of let's say exercise is base R, right? So I'm just gonna check and I'm just gonna put this here and see if it's familiar for people. Is this familiar? Let me know if it is. You can see that it previews the first 6 observations, basically. So it previews the first 6 observations. However, We're using tidyverse, guys. So in tidyverse, actually, one thing you could use is glimpse instead, right? But anyways, I think it's probably up to you guys. If you use glimpse instead, right? So in tidyverse, if you use glimpse, oh, I keep spelling my data frames wrong. You get something that looks like this, right? So I would actually say that probably a lot of the times you still do use head of your exercise just because it looks a bit better in terms of, so in this case, I will say most of the time you probably will use head of the data frame, right? So in terms of presentation, it probably looks better to use tidyverse, right? But anyways, you display enough so that the audience can see what the variables you're working with happens to be, right? Now, the good thing about, the good thing about tidyverse is that it tells you what your variables actually are, right? So if you look here, you can see that you're working with you're working with a character here, and even minutes itself is in character form. That's something we have to work with basically. So you can see that the reason why I'm using glimpse here is because you see how it says character. It means we have to change this to numerical value. Otherwise, we actually can't work with these. We cannot, it wouldn't make any sense to work with this. We probably need to change minutes to make it's numerical. As is right now, it looks like it's expressed as a character, which is not what we want basically, right? So I'm just gonna make a note here. As an aside, it seems that minutes is expressed as a character, right? We probably need to change this to a numerical value, especially because in the next question is make a suitable plot this data frame. Does anyone notice something interesting about the other thing I want to point out is that there's anything note. So whenever he asks you questions like display the data, you should at least state what you saw. The one common mistake students make is that they actually just display their data and move on. This is sloppy, right? At least state what you saw, basically. Just make a note to yourself. Make a note to the grader, right? Make a note to the grader that you have X amount of rows and Y amount of columns. It's just good practice, right? Like, don't leave your reader hanging. Don't just preview your stuff and move on. It looks sloppy, right? Try to be a bit more careful. So in this example here, in our case, we have 29 rows and 2 columns. You state that. So I don't just glimpse your preview data and move on. Even if he doesn't ask you these kind of things, indirectly, if you want full marks, he's asking you to be very explicit as possible. And if you actually know Ken's solutions, they're extremely detailed. He provides more detail than the question actually asked. And some level, he expects that too for the answers you provide, right? So don't just preview your data and move on. Try to take the time to explain what you saw in your data. It's just good practice, right? But now let's see what happens if we don't actually try to change, because remember I said that this is actually, the minutes is actually a character. So let's see what happens if we don't try to change this to something that's actually numerical. So let's see if we can even actually work with this data frame to plot anything. So if I do exercise, a yes. And actually, just want to check something. Let me just do this first. A yes. So first of all, this is a 2-level variable for gender, which means that if we want to look at the mean of exercise level, we might be curious about the mean of exercise as a function of your gender, right? So we might care about the box plot as a function of your gender. So maybe what we look at basically is something like X equals, I guess, minutes, right? And then something like we need to make a box plot here. Box plot. But I want to add something here, like a factor, right? So I haven't made a. Let me see. I want to just double check something, right? So I need to factor based on something, right? I need to factor based on the gender, and I actually just need to really remember because I forgot. I haven't worked with box plot in a while, so a factor based on 2 levels, geom box plot,
right? So I'm basically gonna make, so sorry, this is me being a bit sloppy, right? But you can see that I know I have essentially a variable that in my here is exercise that that's based on a couple of different levels basically, right? So this is not what I want. What I want is this. Yeah. So let me see about x equals f2. Yeah. There. I think it's y is equal to. There you go. I think y is equal to. Sorry. Yeah. Y is equal to, in this case here, gender. And I should really say as dot factor. Let's check something. Yeah. Let's see. What did I do? Oh yeah, that's, so you can see that there's an error here. You see how it says object minutes not found. So first of all, we have to change, we have a problem. And in fact, there's an error in this code because there's a problem with our variable minutes. If I do something like mean of minutes, it's going to tell me that it's not numerical, right? So let me just double check that I have minutes in my thing. Oh. Let's see. Did I attach my data? I did. I just want to check exercise. Yeah, so it is there, right? So let's see. Why is it not? That is so strange. I think it might be, so it's very sensitive here. This is very strange. Okay, let me see. So I'm going to check my data frame. Yeah, it's called minutes. So why is it giving me issues? It's very strange. Sorry. My data set has attitude. Oh, that's it. So you see, it's very sensitive. I'm gonna do something quickly here. So I don't like this. You see, I don't like variables that are very picky like this. Notice that it's not actually minutes, it's like minutes quotation. I don't like this. So I have to change this, right? This is not something I like to work with. So I'm gonna do the following. Minutes equals this. You see that sometimes this is another good point to notice. There's syntax issues sometimes. So it's not actually minutes. The variable is actually called quotation minutes. And that is something I'm not going to deal with because that's another question, another reason why, Eddie. When you said, is it okay to use $, data set $, sometimes, yeah. But the problem is that you can see that sometimes your variables are kind of horrible to work with, and it's just easier to attach the variables and then change the variable label. So sometimes, yes, you can use data frame $, variable, but you can see when you have things like this, you have very picky syntax, probably you don't want to deal with that kind of thing all the time. So you just want to attach the variables and relabel it. So that's one thing I was dealing with as to why, but then you'll see here that the other problem is that I don't think I can take the mean of this thing, because you can see that it's not numerical. So even though I change variable label, I can't take a mean of this thing until I change it to something that's numerical, right? So notice that it's a character, then I have to actually change it something that's numerical. So this data set has lots of things I have to do to it basically, right? Before I can actually work with any of the variables, which is kind of one reason why I chose it, because sometimes you don't get things that are nice to work with. Now I can take a mean of minutes, right? And I'll just show you guys here. Now it's a numerical value. Please check. So the reason why you should not just, you need to use tidyverse, because if all you do is display your data with head, you wouldn't actually see, head does not show you the type of variables you're working with. You need to use tidyr to see, and tidyr under the glimpse function shows you that, for example, your minutes is character. It literally tells you the minutes is character, and you have to change it, whereas you wouldn't see that using head, right? So okay, now let's see if I can work with my tidyverse thing. I can, right? So I get this. Probably if I wanted to be very picky, I would rotate it, right? But you can see that I know that it's, so what happens if I don't put this gender thing, right? If I just put this here, what do I actually get, right? What happens? If I just put this here, I'm going to get one giant box plot, which is not informative. So you can see sometimes he won't even tell you what type of plot to use. And in fact, all the question says is make a suitable plot for this data. Every year without fail, some student does this. And is this informative to you guys? And if not, why is this not informative? So every year I get this. And do you guys think this is informative? I mean, like, what's wrong with this plot? This is a point for discussion. So what's wrong with this plot here? Do you guys think? Anyone see the problem with this plot? There's no like, or just a wrong answer. Anyone should take a stab at it. So what's wrong with this plot here in terms of like whether or not it's suitable? We could change the axis labels. Yes, we probably should. Yeah, that's the problem. So yeah, we could change the axis label to add things. So you guys are both making good points. So let's do that. So just to be clear, they're saying you don't actually have, so I'm gonna do that now. They're saying what you don't have the following. So your X label is not informative. That's a good point. Please make sure you make your X label informative. Minutes. This is probably of exercise. This is probably actually minutes of this is minutes, and then we could probably put Y label. Just I guess this is just I guess the frequency, right? But then there's still a problem with this plot. So what do you guys notice? I mean, what is your variable? What does your variable gender contain? What does your variable gender contain, guys? There's 2 levels to gender, right? But you provided a box plot with just one overall grand mean. This is not informative, guys. So when you're asked to make a suitable plot and your variable has 2 levels, this is not appropriate, guys, right? So it is not appropriate to present a plot where you cannot determine the mean differences between the 2 groups you're looking at. So please, and I expect everyone in my tutorial section watching this not to make this mistake where they present a box plot with 1 grand mean. Which in some sense tells you absolutely nothing, basically, right? So let's change this. Oops. So I'm going to do as.factor, and as.factor tells me that it's 2 levels, basically, right? That it's a discrete variable with 2 levels. Why is it giving me issues? Oh, this is mine. Cool. Right, so and I'm going to see if I can make this a bit nicer. So I'm going to steal the code from online because this is not very colorful. It looks horrible, right? So you can make your plot pretty too. I'm a sucker for. I also spend a lot of time making my plot look nice. So let's see what each thing does. So I know that my Y is as.factor, so I'm going to change it. Gender, and then my X here is minutes, which I changed, right? Fill is going to be, I guess it's going to be just in this example here, let's just fill based on gender, I guess. That's the only variable we have. Theta is exercise, and then geobox. Let's see what happens when we do this. So the fill is just telling you how to, the fill is telling you you're going to fill based on 2 levels, basically, right? So let's see if this runs. I always make stupid coding mistakes. It's like, it drives me nuts, like even during my demonstrations. Okay, anyways, you can see that the fill here is saying fill it based on the Y variable. You might say, why are you filling based on this? I'm filling based on this because I know that there's 2 levels, which means that since there's 2 levels to Y, it will change the fill, it will give me 2 different fills, right? Which is actually really a lot nicer visually than just putting a clunky white plot. So I'm just trying to give you guys as much information as possible to make your graph look as pretty as possible. Then like you said, we should make sure our labels are nice. And you can see here that it gives you some really good information. And in particular, I can actually see that on the median for, so you can see here is that the median for exercise for females is slightly higher than men, but it looks like there's overlap in the distributions, right? So what I would say personally, so once he says make a suitable plot, it is not okay to make a plot and move on. So you can say that from the plot, it appears, actually, I guess I'll leave it here, because you can see here that this is where the next part is. But you can see, even though, so he's anticipating the fact he wants you to explain what you saw in your plot, right? But if he doesn't say part C, does there appear to be a difference, right? Please, please like state your thing. Don't just make a plot and move on, basically, right? So you can, so the default for ggplot is actually presented horizontally. The reason for this is because you can actually see the distribution's shape when you have it horizontally. So for instance, I can see the male distribution is shaped, is skewed to the right? So it's because it has a long right tail this way, and the median is slightly closer to Q1, but you can actually flip it. So I think there's something called, I think you can actually flip this using a coordinate. And if we have time, I'll actually flip it for you guys. You can actually flip this to make it right side up if you'd like to, right? I think there, you can actually flip this. Right, and I wonder if we just do the following. I think it's possible to actually flip this. Let's see. Like this. Let me just see. I think we can actually just do this. Let's see if it actually flips things. So the reason why it looks like this is because you can see it's actually right skew. Like if you pretend you drawing over this thing, then if you just draw like this, you can kind of see it's right skew for the males. For the female, it's kind of ambiguous, right? Because it kind of has a long right tail, but then you can see that the actual median is closer to Q3 than Q1, which is confusing, right? So we cannot confidently say that the female distribution is right skew because the median is actually closer to Q3, which is indicative of left skew, but it has a long right tail, which is indicative of right skew. So it's a bit confusing. We'd probably need to make more histograms or stuff to look at the female distribution, right? But let's see what happens if we turn this around like this. Nothing, right? So I think there's actually a function which you can flip it. There, I know for sure there's a function you can flip it. I think this is a new change where it's decided to display it horizontally. I can definitely flip the coordinates, and when we run towards the end, I'll definitely flip it if you want to see how it looks when it's when you actually have the distribution, so that it's, because I think most people are used to seeing it kind of like this, maybe like where it looks sort of like this, which is fine. I can kind of do that towards the end if people are curious about how that looks. I think they started recently putting it horizontally because, for instance, when you look at the male distribution, it's kind of like this. You can kind of almost imagine it's right skew. That's what they're trying to show here when they flipped it. But I definitely can see that it's not what you're used to seeing, and I'll show you guys how to flip it at the end. Okay, but now let's kind of get some explanation. Let's kind of get some interpretation here. If you don't use, so that's a good question, Michael. In this example here, if I don't use as dot factor, there's no problem. Why is that? Because gender is already categorical, right? So it's not going to matter here. Right, I'm going to make a note, right? So, so the question is actually it's important that I'm actually making a note here. Note. If I do not use as dot factor gender, right, there will not be any real difference, right? In this variable here, because gender, female, male is already dichotomous. It's binary, basically. There's only two levels, and it's a nominal. Anyone heard the notion of a nominal variable? Right? Nominal means that it differs in quality, but not actually numerical value, right? So differing in levels, in quality, not numerical value. The problem is, though, if you have I'm gonna now in general, please use as dot factor variable. You might say why, right? So the why is a question, right? Now the answer is simple. What if your variable has the following levels, right? X is equal to C 4, 4, 6, 6, 8, 8, 4, 6, dot, dot, dot. And actually, this is actually present in the empty cars example. This is clearly a 3-level variable. This is clearly a 3-level variable. But since the levels look quantitative, discrete, if you do not put as dot factor, it will take an average. It will take an average, and your box plot will look messy, look off / messy. See, the problem is that when you run into discrete variables where the levels are quantitative, but it's still clearly 3-level system, it will look really silly, right? So as an example, take a look at empty cars, right? So if we look at empty cars, you will see that CYL is literally a 3-level variable, right? So as dot factor CYL, right? So as dot factor CYL. Oh, that's because I need to actually empty cars CYL. You can see that there are 3 levels. It says levels 4, 6, 8. However, because they're numerical values, if you put it into ggplot without doing as dot factor, it will actually take a mean and you will not get the box plot you're looking for. So that's the reason why you put as dot factors. In this example, it doesn't matter because your variable is clearly actually qualitative. When you have levels that look quantitative, it matters. It will make a mess of your plot. Is that clear as to why you do it? Let me know. Cool. Okay, so now let's have a look at the thing here. Does there appear to be a substantial difference? What do you guys think? Let's look at the box plot. So for the first question says, is there a substantial difference basically, right? In the average amount of time that males and females spend exercising, explain briefly, average, mean, median, or mean, which is it here? So you see he's being a bit careful here. He's asking you to look at the box. If you use a box plot, which you probably should, it's the best one. What do you actually see here, right? What is the actual difference? What is the average referring to here? And does it appear to be significantly different? So first thing here is, what is the average is referring to, guys? What do you see as the average? Like, what is the average is referring to? Is it the median or the mean? Based on what we drew. Is it the median or the mean, guys? Anyone have any guesses? So this good guess, but then the box plot actually gives you the median. So it turns out this thing here, guys, is like Q1. This is Q3. The median is always positioned inside of Q1 and Q3. So this means that here's the median, right? For, I guess males. Here's the Q1, here's Q3. Q1 for females, median, Q3, right? So it turns out the average here is actually referring to median, which probably actually makes sense. Does anyone know why we probably should use median and why a box plot is using median? The reason why a box plot uses median is why exactly? What happens if you have outliers, the mean? Anyone know? What happens to the mean what happens to the mean if you have outliers in your data? It bounces, exactly. The mean completely bounces because the mean is what? The mean, guys, is truly a sum of all the observations over n. It will bounce erratically. If any of the xi's are too high or too low, it will literally bounce. In this example here, the mean is going to be really high because it's because the tail is to the right. It will bounce up because you have large x values. If the distribution is left skewed, you'll have very low values to the left, pushing the mean backwards. It bounces badly to bad skew. Whereas the median does not bounce like that, basically. So when you have heavily skewed distributions, you probably should use the median. And that is why box plots always report the median and not the mean, because it recognizes that if your distribution is skewed, then the median is better than the mean. If your distribution is symmetric, and hey, the mean and the mean are the exact same. You got your mean and your mean, they're the same, right? Otherwise, you probably shouldn't use the mean anyways. And that's why we should make a note here, right? That actually the average here, you know, the average here refers to the median. Right here refers to the median, right? This is because when your distribution is heavily skewed to the left or right, mean bounces. I like that word, I'm gonna use it. With these, you know, high or low values. median sort of sits in the same region, right? This is why. Box plot reports the median. And as it turns out, the median for females is actually slightly higher than men. Slightly higher than males in terms of exercise, but there is a high degree of overlap. In fact, you can actually see that the IQRs, which is literally the spread of Q1 to Q3, is kind of consistent across the distribution. So I wouldn't necessarily say it's significantly different, right? So that you can see that the spread is kind of similar. They overlap. It's not significantly different, right? This does not appear to be significant. Because there is a high degree of overlap in the spreads of the distribution, right? You can actually see they cover each other, right? So while there is some kind of difference, I wouldn't necessarily say it's like that big of a deal, right? Does everyone agree? Anyone disagree? If so, how come? And if not, what do you guys think about question D, where it says, so do everyone agree in agreement that it appears that the distributions kind of have a high degree of overlap? If so, let me know and just say, yep, that appears to be true. So by overlap, I mean that, that's a good question. I mean that, so, you know, I'll make a note here. By overlap, I mean the regions of Q1 to, you know, Q3 exhibit a high degree of overlap in the two distributions, right? So you can see here that this is Q1, this is Q3, this is Q1, this is Q3, and they're kind of similarly spread, right? I wouldn't, the way you would actually notice a big difference if you had something that looked like the following, like maybe you had like one distribution was here, right? The other one was like this basically, but that's not what you have here. In fact, what you see is that they're kind of high degree of overlap, right? Is that more clear? Cool. So everyone agrees, and having said that, it appears that they kind of have similar spreads. So the last thing we have to think about here is it says that for data like this, why does it make practical sense that the distributions are skewed to the right? So I kind of talked about this last class, but the thing I like about this particular distributions is that the female one looked funky, right? So for the male distribution, it kind of has a very obvious pattern. So let's recall what it means to be skewed to the right. Recall, right? Right skewed means the following. One, Q1 closer to median than Q3, right? And then the second thing is that you have a long right tail. So if we think about this, it actually means your distribution kind of looks like the following thing. It looks something like this, right? Where your mode is closer to low values. Your mode and median are lower values. That's why the median is closer to Q1. Q1 is truly low, and it's very unusual to have high values. So the reason why Q1 is closer to median than Q3 is because Q1 should be the mode should be closer to high values because it has a long right tail, meaning that the mode should be closer to lower values because a long right tail would indicate that the chance of being out here has lower frequency. So most observations are clustering around lower values. So your median should be closer to the lower values than high ones. Whereas the opposite is true for less skew distribution, and you have a long right tail. Now, the third thing I should point out is, but you won't necessarily know here to point it out, is that you have the median is actually less than the mean because the median is closer to the mode, right? Which has to be at the bottom, right? Now, I probably wouldn't use 0.3 in your analysis here because you can't actually see the mean on this data set. The box plot doesn't plot the mean for you. So it wouldn't make any sense to talk about the mean, right? Like that. You probably should use points 1 and 2. So now let's look at our plot. I can see, guys, that for the males, Q1 is slightly closer, the median is slightly more to the right than it is to the left, but this has a very long right tail. It's very obvious it's right skewed. With the females, it's not that obvious. Why? Because it's strange. It's certainly not obeying option 2. It's not obeying 1, right? You can see that, in fact, here, the median is closer to Q3 than Q1. The only giveaway that it's right skewed is that it has a long right tail. So it's a bit more ambiguous for females. And probably if you wanted to be very picky, you'd make a histogram to see it better, right? So I would say that for males, it's obvious, right? For the male distribution, we can see that the median is closer to, Q1 than it is to Q3. And it has a long right tail. This is right skewed, guys, right? For the females, it's not as obvious other than a long right tail, because we have that Q3 is strangely closer to the median than right Q1, which it's not what we expected. So probably for women, I probably would just have a quick look at the histogram to confirm that I think it's actually right skewed. I'm going to do it quickly in the last minute. So exercise. I'm just going to check to make sure that it actually makes sense to me that it's, right skewed, because it's kind of odd, right? So if you want to make a histogram, it's geom histogram. Right, I'm going to make a quick one and see what we get. Oops, that's the wrong thing. It's minutes. Yeah, there you go. So you can see that there's a problem here. I need to change the bins to be equal to, let's say, 10. The reason why you have this spacing, guys, is because there's not enough data for the number of bins I have. The default is to use 30 bins, but the data is too sparse to use that. So I have to instead cut it to 10. You can see the shape is coming out more clearly. Might even go a little bit smaller, make the bins 5 instead. And the shape really comes out. So it really actually is right skewed, although it's clunky. So it doesn't look as nice, I guess, as and I guess I'll just say fill equals red, just make it a little bit nice. Color equals black, right? So you can see that it certainly is actually right skewed, but it's clunkier than the other distribution. However, looking at this histogram, we can confirm, right? This confirms that it's actually right skewed as well. This confirms it's right skewed as well. Oops. So I'm just going to say this confirms female distribution is right skewed as well. So sorry guys, making you go over. I will, flip the ggplot 90 degrees afterwards for those who wish to see it right side up, right? So I'll do this for you guys before I post it to my GitHub. Remember, I give you a link to my GitHub and it will be on my YouTube page. So I'm just gonna, right? This is my YouTube page if you're curious as to where to find me. I'm going to put it in this chat. So it is here if you guys want to find it. Other than that, I guess I will see you guys next week. And hopefully this tutorial helps you for your first assignment. Otherwise, if not, you can put it in the discussion board and I'll have a look. But have a great day, guys. See you next week. I'm going to pause. So just as a reminder, for those of you who don't know where to find the recordings after the tutorials, I always put them where? Let me see. I always put them in my GitHub here. So I put the lessons in my GitHub, right? And then the tutorial, I actually have them. You will find the, oops, that's not mine. Sorry, you will find my worksheet, you'll find my thing here. So if you want to watch the thing after class, you will find it here. I think I put this also in the discussion board, but obviously people might be watching one week and not the other. So I'm just gonna, for the first couple of weeks, make sure I state it so people know how to find it. Anyways, again, we are using tidyverse. At some moments it might be appropriate to use base R, and I'll point it out. So what I'm really going to do in this tutorial is I was telling the other tutorials, I'm going to kind of give you kind of intuition as to how to structure your assignment, because I think it's released today. So little tricks and trades as to how to do well in an assignment, because sometimes Ken has something, there are some things he wants to kind of to include in terms of formatting, but he may not explicitly state it. So to achieve an 80 in the course is doable if you knew how to follow on with the material. To get a 90 plus, it would require a bit of thought, right? And learning the tricks and the trades to really make yourself exceptional, which I'm going to try to elucidate, at least for the first assignment, how to do well, how to go from like an 80 to like a 90 plus. So first of all, the first thing is to be mindful of the fact that like when you're loading your packages, you can see that if I load tidyverse, right? The problem is that it does the following. So I guess I'll clear my environment just to start again. If I load tidyverse, it does the following. Oh, it's because I put false. Let me remove this to show you what it does. I'll just put true actually, because I'm too like lazy to change the thing. If I just knit this to HTML, you will see that the first thing that you don't want to do in your assignment is to do this. You see, the problem is that if you don't put warning equals false, it will load that it's built under version 4.05, right? So in putting warning equals false, what does it actually change? It does the following. Which is still not good enough, because the warning is gone, but the actual loading of the packages is still there because the messages are still true. You need to set everything to false, right? Because that is an eyesore to TAs, and without fail, somebody always has that loaded. But when you're getting marks for cosmetics and how you present your ideas, you certainly don't want to have loading the packages and warning signs coming up. It doesn't look good, right? So try to remove it. Right. The other thing you might even want to do that for here. You can see how it's giving you the column specification. You might want to even block out the message there, and let's see if we can actually do that, because those kind of things we actually don't really need. It doesn't look good, right? So let's see if we can even block it out for that too, just because those kind of things don't. What you really want is the code you did for particular manipulations in the output. You actually don't want the messages in your output, right? So whenever you see loading things that look strange, you might want to put message equals false or warning equals false to hide it, right? Those are the things you don't want to show in your report because it doesn't look tidy. So please hide it, right? Now, I don't know if I've ever showed you guys, but ironically, if you do the following, echo equals false, and you knit the PDF, right? What you will actually see is that it removes the code, and all you got is the output. You see remove the code here. It removed this code over here. Please don't do that, right? So in general, for this course, you will actually want your code to show. The default is actually echo equals true. So it's only when you want to actually hide your code would you even write echo equals false. Otherwise, the default is to show the code. But we want to know where you got your output from. So the only thing you should really be, for now, manipulating in your actual R chunks is the message and warning. Please don't, because some people think that they want to make as their output look as smooth as possible. So only include the output, but please include the code. We want to see it. Anyways, this is an exercise from Ken's book on his site, the PSAISAS, I think. It's actually exercise as is a function of like your gender. So there's actually 2 levels here, female or male. And then the minutes it takes each person. So the first female took 60 minutes, second female, 240 minutes, third female, no exercise, etc. Right? And you can see that it's actually almost tidy, merely because they've actually segmented the data in 2 different perfect splits, right? But anyways, when you want to load this data in, because the fact that it's separated by a single space, you want to put this, not this. This is not indicate, this doesn't indicate anything. You have not actually said what the actual separation happens to be. You have to actually state that it's a space for it to actually load. And then when you run it, you get your variable. Now, somebody actually asked in the previous tutorial, why do we attach, or can we not attach our variables? I said to them, if you don't want to attach your variables, you will always be confined to doing the following. You'll always be doing exercise, $, calling your variable, which in this example here actually isn't optimal because of the fact that the variable for minutes is actually a bit untidy. We have to tidy up the variable minutes a bit. So it's better to actually attach your variables and work with them without having to do the $, because quickly you get confused with variables. If you have to keep pulling and extracting using the $, so just attach your variables. If you no longer, if the fear you have is that you're gonna override particular labels, when you no longer want to work with a particular data set, you can always detach it. So I put this here that you can always use the detach function. And if you use the detach function, all the variables are stored in the global environment that allows us to do something like this. Or sorry, that allows us to do this without having to put $, it will go away, right? So I'm going to say that, this question. Would attach, detach count as some of the things that bring an, not necessarily. So, okay, that's a good question. The question you're asking is that should we actually use the detach function or attach function? As it is right now, you probably should attach your variables just because it looks tidy. I would say that it's not really a big deal if you don't attach it yet, but obviously the cleanness of your code does kind of matter. And if you keep using too many $, it eventually does look a bit sloppy. Sure. I wouldn't say it's a big deal in this data set merely because you only have 2 variables, but yeah, you can imagine that if your data is very untidy, if you have a lot of variables and you keep using $, quickly it becomes hard to follow. And then you may lose marks for presentation, right? So I guess on some level, you kind of want to make sure your data, your code is readable, right? That things look clean. It's just that at the beginning, we work with such small data sets. I wouldn't necessarily see where it would be a big issue, but you can imagine as things get more difficult, you might want to try to make your code as nice as possible, which might entail trying not to use like trying to make it clean and not having to, it makes sense not to have to call your variable from the data frame every time. It's better to call it from your global environment where it's stored instead of having to call up your data frame every single time you want to perform an operation, right? And in particular, this particular data set is a bit tricky, right? Because this data set's a bit tricky. I'm going to defer from this, but I will say when I post this lecture, I encourage you guys to watch this part. Somebody was asking earlier on what the difference is between tibble and data frame. And you can actually see it. What I did was I actually created a data frame where I actually showed that the tibble and data frame are not quite the same object. So in theory, they operate in the same way because they both create a 6x2 data frame. When you want to work with tables, the object table data frame is a bit different from a data frame itself. So when you want to work with tables, like looking at like, if you want to do like those 2x2 tables that you sometimes do when you want to look at proportions or stuff, sometimes a table is better equipped for that than a data frame. So in theory, they kind of operate the same, right? But in practice, not really. When you want to do table stuff, which you might see later on, you might want to do a tibble. tables within tidyverse, but I talk about this extensively in the recording, so have a look and see. But let's look at the questions that Ken has. So I'm going to the exercise that Ken actually did. If you have any questions, certainly feel free, and I'm going to amend the data frame, or I'm going to amend the file as people are asking questions. So this means that the overall grand file will look different according to the questions both the morning class asked and also you guys. So which means that when you watch the recording afterwards, you're going to see that the overall file reflects what you guys set together, two of you. Okay, so it says read, then display some of the data. I did say that sometimes you might want to use base R. This course is really looking at tidyverse, so for the most part, probably not, but there are some instances where base R looks better than tidyverse. This is one of them. When he says read and display some of the data, if you use head of your data, which is actually built in, you get something that looks like this. It actually looks better, right, than what you get with the glimpse function. So glimpse is built into base R. Sorry, glimpse is built into tidyverse. So you actually cannot load the glimpse function until you actually call the tidyverse package. And you actually see that it looks like this. So when he says display some of the data, it may actually look better to use the base R instead of tidyverse. There are some nice things you get from tidyverse, right? So sometimes tidyverse gives you a nice way of knowing the variables you're working with. So for instance, tidyverse tells you how many rows and columns you have right away. So if he's asking you things like display your data, and he adds it up by saying, tell me some features of your data, you might want to say from our data output, we can see that we have like this many rows, this many columns, etc. Right? I will say that if he asks you to read in and display some of the data, and that's all he says, I would still kind of write what you saw, right? So if you look at his solutions, you will notice that he has more detail than he actually states in the question. So with Candy, it actually is not a bad thing to give more information that's good, more useful information. Don't just write a book for no reason, but if you're asked to read and display some of the data, it certainly helps to say that, we can see that we have two variables, right? Gender and minutes. There are this many rows and columns. Be explicit as what you saw when you preview your data. Don't just preview your data and move on. That's lazy, and it doesn't necessarily always generate. It can generate full marks in the sense that you'll get an 8 out of 10, like you'll get a high mark, which you may not get 100% or like 90, because you did kind of like, you did enough to get a decent mark. Maybe your report was not exceptional, basically. Things to consider. All right, but does anyone see what's interesting about the minutes function or the minutes variable? There's a problem here. What do you guys notice? There's a bit of an issue here. Anyone see the problem? There's a problem we have to address here. What is it? That's one issue, John. So one issue is that John is saying that, like, how come the minutes is like, instead of how you see there's a quote, it's almost like it's kind of some kind of exclamation or something. That's one problem. There's another one. As long as the other issues. The one problem is that the way the minutes is expressed, I don't like it. We have to fix that, because you can imagine this is going to become a syntax nightmare to work with if we don't relabel this variable. That's one problem. But there's another one. Does anyone see what it is? Minutes is usually what kind of variable? It's quantitative, right? Minutes. What do you see in your actual variable? You can see it's given as type, right? So it's given to as a character, when in fact minutes should be quantitative. That's something we have to think about, basically, right? So when you wanted to do any kind of graphical display and you have both your variables are qualitative, that doesn't help you. And in fact, we know that minutes is supposed to be a quantitative variable, so that we have to address this, right? So two things you have to do is probably relabel our variable because it doesn't look great, right? And then we need to kind of change it to numerical value. So when Ken asks to make a suitable plot for this data frame, before I even think about what kind of plot I want to make, I need to change my variable so it doesn't look like this. You guys pointed out, but this is difficult to work with as a variable, because you can see that it's so sensitive to syntax that if I don't change it to minutes, even if I shift it over to the right by mistake like this, and I try to run this variable, it won't run like this, right? You have to do it like this all the time, which is just really difficult to deal with. So I need to relabel that as something else, right? And it will come out at 7. Not yet. I heard it will come out at 7 today. And I think usually you get like a certain amount of days, maybe a couple of days to work on it. As I think that's what he said, right? You get a couple of days to work on it, then you resubmit it. Yeah. So you can see that I don't want to deal with this because even if I shift up my syntax to the left a bit and I do this, then this will no longer load as a variable, right? So if we change to minutes, we can, not even have to deal with that, but just labeling as something that is just something easy to work with. But now notice that if I take the mean of minutes, it will tell me that it's not logical because you can't take the mean of something that's a character or type. It has to be numerical, right? So this is another issue we have. This means that if we cannot take means, we certainly cannot compute any kind of graphical display that's depending on numerical values. So we have to change this to something that's numerical. So I'm just going to put as.numeric. This is built in actually into base. This is base R actually. It's a function of base R, but now you can check to see that it's actually numerical because if you do mean of minutes, suddenly you can actually compute it, right? So this is now a numerical value. Now, what do we actually see? So what do you guys think would be an appropriate box plot for this data, or an appropriate plot for this data? The minutes is continuous. So there's only 2 types of plots. There's like 3 types of plots you can make: a scatter plot, I guess, a box plot, and a histogram. So you can obviously see that I chose box plot to be the best one. Does anyone know why I chose box plot to be the best one? Not histogram or scatter plot, because these are things we need to think about, right? So he's not always going to tell you make a box plot. He'll just say make a suitable plot. You have to know for yourself what is suitable relative to your data. And if you make the wrong plot, it doesn't result in full marks. So you need to think about this logically, right? So why is a box plot the most suitable plot here? Why not a histogram or a scatter plot? Anyone know why? What do you guys think? Anyone? No. What do you guys think? We can find the range of outliers with histograms too, right? Histograms also give you the shape, basically. Histograms also tell you the range of outliers, right? So the data is small, which is going to be an issue for sure with histograms, but there's ways to address that. There's another good guess. The real problem here is that we want to compare 2 groups, that is female and male. We want to compare their spreads. If you want to compare the spread of 2 distributions, the easiest way to display it is through a box plot basis. So again, if you wanted to compare the spread of 2 distributions, the best way to actually do that, right, is to look at the box plot, guys. This is why, right? So if you do a histogram to compare 2 groups, it looks sloppy, and it's very difficult to compare. It's difficult to compare. A box plot gives you a better way to assess distributions than histograms, or at least it gives you a better way to display subtle differences in distributions, most of the histograms. This is why we choose it, and especially because we have 2 different groups, and that female and male, and it's dichotomous. So we're going to get 2 different box plots on the same grid, which allows us to directly compare their distribution. So if you have 2 different box plots on the same grid, you can actually compare the distributions, right? I'm going to point out a common mistake students make, right? So you can see that common mistake students make is to do the following. Does anyone see the problem with this graph? I mean, I always, without fail, whenever I'm grading graphs as a TA, I always get this kind of thing. Somebody always does this. It's not legible, but the biggest problem is that you're trying to compare 2 groups, right? You're not looking for a grand mean of distributions. You're looking at a comparison between male and females. This graph gives you nothing basic. It's not suitable. It gives you absolutely nothing. You're not asked to plot a box plot of the grand mean. If you have 2 different groups, you can imagine you're making a comparison on their difference in mean exercise. It doesn't make sense present a box plot with one whole grand mean. Because how can you compare female and male's average exercise distributions in a box plot like this? You can't see anything about the distribution shape of males versus females. It's not a pseudo plot. So please think about this, guys. The minute you have a variable where there's more than one level, by more than one level, I mean whenever you have a discrete distribution where you have more than one level, you already have more than one, and you have female versus male, you cannot, a suitable plot is not a grand mean box plot. Instead, what you need is to recognize that you're trying to partition based on a gender. This is why I have y equal to gender, because it's going to split my data into two, right? And then recognize that it's going to partition based, it's going to look at the, it's going to give me two box plots according to gender. Now, the fill gives me a way to color my graph. If I don't actually put fill, what actually happens? We can actually drop layers and see what happens. If we don't put fill, what do we get? We get this. You can see that it gives you information. It's just not as pretty as it could be, right? So if you really want to get the split, all you have to do is the following, but I actually like to fill, right? So I get a colorful graph. So if I fill based on the discrete variable, it will give me two different colors. If my variable had 3 levels, it would give me 3 different colors, right? So it's going to fill based on the number of levels you have of your variable. Here we only have 2. Somebody asked, so I initially, when I was doing this graph, I actually did this, right? And we got into discussions of class, as whether or not you needed to put factor. I'm going to talk about this here as well, because I think it's actually important. So I got into discussion about this, and somebody said, do we need to put as.factor, because didn't they both run, right, without it? And I said that for this particular example, because gender is differing in quality instead of numerical value. So you can see that gender, right, is it's a variable with 2 levels of different quality instead of quantitative value, right? Because it differs like this, you don't need to as.factor. Why? Because it already recognizes there's 2 different levels and they're not quantitative. The problem is, though, that when you have variables that are still actually factorable, they have 3 different levels, but the levels are expressed as numerical values instead of things of different quality. If you don't put as.factor, it will actually give you a grand mean as a box plot, and it will not make any sense. So as an example, there's a data set called empty cards, which I talked about last week. You can see that CYL actually is a discrete variable with 3 levels, basically. Oh, sorry, I need to actually define. You can see that CYL is actually a data set. Sorry, it's actually a variable with 3 levels, basically. You can see that 4, 6, and 8 are 3 different levels. It's not supposed to be a numerical value. It's supposed to actually be a qualitative variable with 3 different levels. The problem is, though, it looks like a quantitative variable. So if you don't put as.factor CYL into ggplot, it will actually take a grand mean of 4, 6, and 8, thinking it's numerical values, and your plot will look off, right? So if your variable is qualitative, different in quality, maybe you don't have to put as.factor, but as just as a cautionary thing, when you have things that are, you probably should just put as.factor to avoid situations like this. And you can actually play around with it yourself and see what happens, right? So when you don't put as.factor, see what happens to your box plot. Probably we can actually check and see if we're curious, right? So let's see if, we put ggplot, empty cars, and let's suppose we're curious about, I don't know, maybe we want to know the box plot of, what's in the empty cars data set? Let's see. I guess let's look at the weight, I guess. Let's look at weight. So let's look at x equals weight, right? And let's say we have y equals CYL, and then we do plus geom box plot, right? You see that it does this. It's like, it says, did you forget to factor a group? It doesn't even know what you tried to do. It just looks scrambled because it's recognizing that CYL is actually quantitative. So it's taking a mean across the whole thing and it doesn't know what to do, right? That's why you have to put as dot factor sometimes to avoid these situations where it's completely confused as to what is going on. Because once I do this, it recognizes 3 different levels. So this is why you actually probably should use as dot factor. I mean, and when you have qualitative variables, a different quality, again, it doesn't matter, but when you have things like this, it will get confused as to what it's supposed to do, and it will make mistakes, right? So this is why as a practice, it makes sense to have good coding and not skip steps where you're not putting as dot factors, just because we shouldn't hack, right? So just because not putting as dot factor works with gender doesn't mean we shouldn't do it for good practices. If we don't have good coding early on, it comes into play later on where we make mistakes like that and we don't know why our code's not running the way it's supposed to, right? So this is something I talked about the previous class, and I thought I'd bring it up again because it's very pervasive. And it probably will come up eventually in the data set you work with. Hopefully that's kind of clear. Just because I felt like if you guys look at the actual notes, you'd be confused to why it's there. So I figured I'd bring it up. Okay, so Ken asks, does there appear to be any substantial difference in the average amount of time that males and females spend exercising? Explain briefly. Then he says, average can mean mean or median. Which is it here? Does anyone know what it is? Is it the mean or the median? Which one is it? Do you guys think? Is it the mean or median? Is it the mean? Is the box plot giving you the mean? Is the box plot giving you the mean here? He's on that delivery. So sometimes he does that, right? He doesn't want to give you the answer necessarily. He wants you to take into perspective the shape of the distribution, right? And to facilitate this kind of thinking, I'm going to actually give you, so last class, I said that there's a couple of things to notice when you're trying to determine the skew in the distribution. Said that something is right skewed when a couple of things are true. Q1 is closer to the median than Q3. And a second thing is that it has a long right tail. And that the third thing, which you won't see in the box plot because it doesn't give you the mean, is that the mean is actually bigger than the median. The biggest problem with the mean is that when you have a long right tail, it means that somebody had a really good way of describing it when they talked about it, when we were talking about it last class, said the mean bounced around, which is kind of true, right? Because the mean is actually a sum of all the observations. It actually will bounce around when you have high values or low values, right? So if your values are very high, it will bounce left to right. If your values are very low, it will bounce to the left and your mean will be very low. That's a problem. It means your mean is not actually, your mean is heavily influenced by outliers, which is probably something we don't want in our measure of the center. The median kind of just sits where it is. You know, the outliers kind of encroach in your data set, right? So the median is a bit more robust to outliers than the mean, which bounces around a lot, as somebody said, because it's a sum of all the observations. When you include those outliers in the sum, it bounces up or down depending on where the outliers happens to sit. That's a bit of an issue, right? So the box does not use the mean because of this. Instead, it uses the median because it recognizes a better measure of the center. And you have skewed data. And this data is pretty skewed because you can actually see that for males, this is Q1, guys. So this rectangle you see here for both of these things, Q1 is always here at the beginning of the rectangle. Q3 is always the end of the rectangle. And then directly in the middle, guys, is the median, right? That's how it always works. But you can see here that actually, the median is kind of encroaching closer to Q1, although it's not overwhelmingly so. For the male, if you kind of cut, you see it's encroaching a little bit more to the right, although not overwhelmingly so. And that it has a long right tail, right? So if I were to actually draw the distribution of males, it looks something like this. Maybe slightly towards the left,
something that looks like this. It looks classically right skewed. It's a long right tail, and it has like Q1 close to the median and Q3. This means it's skewed, so you really shouldn't use the mean. That's why, so he's asking you to think about those things and state it, right? You should state which one is the best measure. You should know these things based on the shape of the distribution. He may not always tell you this. You have to dig a bit more and look at all the characteristics of your distribution to determine what is the best measure, right? You can see for the female, it's a bit strange because I did say something is right skewed when Q1 is close to the median and Q3 is to the median. But you can see that actually here the median is closer to Q3 than Q1, which is weird, right? That's strange. So while the tail is still to the right for females, we probably have to draw another, we need to draw another distribution to be confident in that. We probably need to make another distribution, which I will in a bit, to be confident that that's actually right skew. But anyways, they're both obviously not symmetric. So we shouldn't use the mean, we should use the median. Now, what do you guys think about the distribution of exercise? Does it look like they're overlapping? Do you guys think? Is there an overlap you guys see? Or no, or what do you guys think? Any guesses? So keeping in mind that this is Q1, right? This is Q3. This is Q1, Q3. So the overlap would be kind of in the heavy parts of the distribution. So do you guys see any overlap between the exercise averages? And would you guys say that the difference is radically big between males and females? Like the median for females is slightly higher than that of males, but does it look overwhelmingly so to you guys? No, it's not, right? So you can see there's a high degree of overlap in the distributions, and the median is narrowly bigger for females. So it doesn't look like there's a significant difference. In the box plots, we probably shouldn't feel confident to say that there's a big difference based. So I did say here the average refers to median here. I did kind of make a note here that, right, that we know that when we have a skew, we shouldn't use the mean. But anyways, yeah, the median for females is slightly higher, but we should not be so confident to say it's significant. It looks like there's a high degree of overlap. But somebody asked, what do you mean by high degree of overlap? Last class. By high degree of overlap, I mean that if you have a look at the actual distributions, there's a degree of overlap in the Q1s and Q3s, right? The distributions are really kind of overlapping. Something that would not overlap as much if it looks something like this, maybe, like, right, if you looked at one like this and the other one was like over here, maybe, then you might think that there's like sort of a mean difference, but there's sort of an overlap in their actual distributions here. We cannot say it looks necessarily very significant by the way it looks, right? So you can see the distribution of form is not that great in terms of the actual, the spread is not so radically different between the two that we would say it's significant. If you actually did a statistical test on that mean difference, it might not really actually be significant. And probably at some point, Ken will bring up the sign test or a median test, which you would use if your distribution is too skewed, which should do some kind of statistical significance to determine if your differences are kind of sort of meaningful, right? Yeah, so let's look at the last question here. That I want to show you guys something else quickly about the tabular. You guys can ask me if you have, and then you guys can ask me if you have any questions. So here it says for data like this, why does it make practical sense that the distributions are skewed to the right? And the numerical summaries. So yeah, it says, why does it make practical sense that the distribution is skewed to the right? Does anyone know why? So I did say again, that there are a couple of traits for right skewed. So for the male distributions, it's kind of obvious to you guys that it really is right skewed. What do you guys think from looking at the male distribution? Is it kind of obvious to you guys that it's kind of left skewed? I'm sorry, right skewed? Does it look kind of right skewed to you guys? What do you think? Thoughts? You don't see that it's right skewed? Do you know how to determine a right skewed distribution? That's because that's going to be a big problem if it's not clear to how to determine right skewed distribution. But did you guys ever learn what it means to have in any of your stats courses how to determine the skew distribution? Because I guess that most of you guys took B57, right?
I guess most of you guys took B57, right? No, but just in general, not just even in histograms, you should be able to tell if it's right skewed. Not just in block, but even for histograms, you should be able to tell. That's what I meant. Is that clear to you guys how to determine even in histograms? Do you guys know in histograms if when it looks right skewed? What do you guys think? If not, you can let me know and I can kind of go over like a quick demonstration. Do you guys know what it means to be right skewed, even in a histogram? Okay. So something is right skewed if it has a long right tail. Yeah, that's totally fine. Something is right skewed if it has a long right tail, right? So there are a couple of things, right? So when you have a right skew thing, it's called a right skew is interchangeable with positive skew, right? So what it means is positive skew means that it skews to infinity, basically, right? So right skewed, positive skew, oops, positive skew. So the reason why it's called positive skew is because when you take a mean of things, you do something like this, right? This skew is indicating that this is a frequency, right? This is called this. What you have here is the frequency on the y-axis, right? But the frequency is tapering as your values get larger, meaning that the odds of seeing observations that large is diminishing, right? So what it's saying is that most of your observations cluster over here in the lower values, right? And you have very, very small narrow band that clusters up here, but it's not very common, right? So this is why it looks like this. And usually these pervasive uncommon observations has big effects in the mean, right? Because they're not likely, but they're so big. So when you add them to the sum, it drives the mean up, right? The mean goes up. Let's say it drives the mean up. Because you can imagine that while most of the observations are to the left, you have these outliers that are being included in the mean and it pulls it up basically. As a consequence, your median and your mode are back here. Your mode and your median are over here, maybe. Oh, actually, I want to color code this. Your mode is over here. And your median is close to it. So let's call this the mode. And then, oh well, it's going to stay pink. This is the median. But then your mean is actually pulled up again by these pervasive outliers. So it turns out your mean is actually higher than those two things because the outlier is pulled up by the outliers. And so your mean, and maybe it's somewhere over here, and you actually have the mean is bigger than the median, right? And this is actually why, guys, Q1 is closer to the median than Q3, because you can see your median is very far back. The Q1 is the 25th percentile, guys. Now, if your median is in the low values, of course, it's close to the 25th percentile than Q3, which is the 75th percentile, basically, right? So it makes sense that the median has to be closer to Q1 than Q3, right? So that's the case that the median close to Q1, because Q1 is way back in the, it's 25th percentile, basically, right? Right, is this clear to you guys? You can see that this is why it's like this. So you see that it's called positive skew because you have these really big values of skew, literally your mean upwards, basically, right? So hopefully that's kind of clear. But when you draw this out in the box plot, guys, if I were to put a box plot like this, it kind of looks something like this. If Q1 is somewhere back here, let's say it's 25th percentile. So it's somewhere back here, let's call it like this, Q1, and let's say Q3 is like the 75th percentile or something, right? Then if Q3 is the 75th percentile or something, right? You can actually see your median is closer to the actual, your median is actually closer to that value, right? So let's draw this here. The median's over here. It's actually closer to Q1, which is back here. when you have this long tail. This is why you have a right skew, the box plot looks like this, right? So literally, if I draw out this box plot of something like this, where you can see that when you look at the graph, that's what it's showing here. Do you see it now? This is what it's showing for males. Is this clear as why males is right skewed? If you look at it, the tail is going to the right. You have a long right tail indicating that your graph, you map it out onto the histogram, it looks something like this, right? So is it clear to you guys to why the males are now right skewed? Let me know in the chat. However, guys, the females is weird because I just spent the last 5 minutes or so saying, isn't it true that your Q1 is closer to the median? But look at the female distribution. Actually, the median is closer to Q3, which, by the way, is a characteristic of left skewed. Because if I were to actually draw a left skewed distribution, guys, what you would see is the opposite, right? You would instead see something that looked like the following, like you would have a distribution that looks like this, right? For left skewed, or it's called negative skew. Left skew, negative skew, right? Where now your mode is actually up here and your median is also up here, right? So when you cut the distribution, you get something that looks like this. Right? You get a distribution that looks something like this, I guess. Like maybe your Q1 is way back here. You get something that looks like this, a long left tail, and your Q3 is closer to your median. It looks something like that's the opposite, basically. Right? So we truly expect the Q3 to be close to the median for left skewed than right skewed. But when you look at the distribution for females, it looks kind of odd. It almost looks as if it's doing what you should expect for left skewed, yet it has a long right tail. This is why the female distribution is a bit strange. And we have to ponder about this for a bit. Because what he asked in the question is, he says, why does it make practical sense that the distributions are skewed to the right? Now I'm saying for the male distribution, it's obvious for the reasons I pointed out. It's classically right skewed. However, it's not so obvious for females other than a long right tail. So I had to think for myself, do I think it's true? So I said that for male distributions, we can see the median is actually closer to Q1 and has a long right tail. Bam, it's obvious. But I thought to myself, well, that's not obvious to me for females because of the reason I pointed out. Q3 is closer to the median than Q1, which is not classic for right skewed data. So this is when you use the histogram, because the histogram also tells you things about the skew, because we can see that the histogram and the box plot have to say the same thing. You cannot be the one shows right skew and the other one shows the left skew because of the picture I showed you, right? So I actually made a histogram here using ggplot. I changed the feature by saying geohistogram instead of box plot. Now, if you don't put bins equals 5, it looks ridiculous because of something. Let me see. I think the student, what's your name? Your name is Artem. Is it Artem? Did I say it incorrectly? I feel like
Yes, you got it.
Oh, okay, great. Artem, he was saying, shouldn't you use, maybe we could, the data is sparse, which is true, it is sparse, right? And that's why it was one reason why I didn't use the histogram initially. And if you look at the histogram without doing the bins thing, you get something that looks like this. This looks ridiculous, right? There is nothing you can get from this because the data is truly sparse. I mean that in these bins here, there is no data, guys. That's why it looks like this. There's actually no data inside these bins. And the default bin, by the way, is to use 30. So you have to change the default. This is why I put bins equals 5, because it doesn't look good at 30. You can actually only see the shape when you make your bins like bigger, basically. When you stop asking for fine spaces, for fine grids, and you make your intervals clunkier, as in you only have five different bins instead of 30 different bins, you get a better shape. So you can see that if you make the number of bins 5 instead of 30, you truly actually do get that the mode is looking kind of in the lower values. It certainly looks right skewed, but maybe not classically so, right? Because if I were to, yeah, you can see it looks skewed, but maybe not classically so. And actually, I guess I should really put, maybe I should put a equals as dot factor. Let me see if I can do this. Oh, I can only, yeah, I can't do that for histograms. I would have to split it. Oh, I know what I can do. I want to show for females. So I'm going to do something here. I'm going to filter only females. So I can show you guys what's going to go here. What's going to go on here. Okay. Let's call it females, exercise. So you're going to see the first time I'm going to use filter here in my tutorials. I want to take gender equals to female only, right? So what does this give me? It gives me only those in the data frame that I, identified as female. So if I run this, oh, sorry. There you go. I will get, let's just double check if that's actually true. Oh, I called it females, not female. I always keep doing this, these like gaps in my demonstration. There you go. So you can see that I only have 16 observations, whereas the initial data set, I showed 29. So I've actually cut out the males. And if you can just check and see, right, to confirm it. Right now we can probably check to see what the distribution looks like for female. I did it again, like a goof. Oh. Now it's, so now it's going to be picky here. I have to do the following. So does anyone know why I have to do this? Why I have to put females minutes? It's because it doesn't like, it's using the initial, if I don't call the minutes from the female data frame, it's going to take the minutes from exercise, but the minutes from exercise has a length of 29, where this one only has a length of 16. So it's going to say it doesn't make sense, right? Yeah. Now I have other problems. Just what exactly? Why? What did I do? That's weird. Hang on for a second. Let me see if at least gives me this. Unknown initialization. Oh, yeah, that's why. Oh my gosh, it's gonna make me do all this crap. Okay. Sorry, one more manipulation here. Sorry, it's gonna make me do a bunch of ninja stuff. Yeah, you see that I gotta do a bunch of stuff, manipulations in the actual thing. Okay, let's see. It didn't like the fact that, yeah, it was calling it as a string. Yeah. So okay, now let's see, this should work now. Yeah, there you go. So let me show you I'll tell you what went wrong. Two things. One, when I did not put females $ minutes, it was taking minutes from the initial data frame, which is length 29. It didn't like it. It was saying that's wrong, basically. But once I changed it to females minutes, it recognized that that's not what it was called in the new data set I created. So I had to change it. So mutate allows you to create a new variable, because now if I look at the actual dimension of females, it's going to be 3. You see, it allows you to create a new column that you call whatever you want. So mutate allows you to create new columns on your data frame. So I called it minutes, basically, right? And then that's what fixed the problem. Now if I put geom histogram and I put bins equals 5, fill equals, let's say, red, color equals black, what do I get? I get this. And you can see that it's not great for females. It's certainly sort of right skew, but to me, it looks almost symmetric. That's the problem, guys. I truly believe that sort of, I'll just hit sort of looks, it is almost, right skewed. It is slightly right skewed, but bordering on symmetric. That's the problem. That's why I was confused. It didn't look that skewed to me, and I can confirm enough in the histogram. So sometimes you have to make more than one histogram to point to see it, basically. The box plot shows that it's right skewed from the long right tail for females, but not to the same extent as it is for males, though, Jonathan, right? Or John, right? Because if I would actually filter for only males, you see the box will look better. So let's suppose I filter for males only, filter only males, you will see the opposite happen. You'll see a very strong right skew. So they're not, you can see that they're not equally skewed, right? You would see that it's not equally skewed, right? So if I just change this to the following, right? You'll see that the actual male, the male one is actually slightly more, a much more right skewed. So let's see if I can pull this up and show you guys. You're gonna see that it looks a lot more right skewed. Oh, I don't like this. I meant blue. This is ugly. Yeah, you see that it looks obviously more classically right skewed. So it's definitely more right skewed for males and females, right? Which is why we needed to use the median, but it's not equally right skewed for both of them. The histogram confirms it, right? I did tell the other class that I would just to show them how to flip the histogram up, because maybe they don't want to see it. Maybe they want to see it turned 90 degrees. I'll kind of toggle that code and include it down here when I post the final version. Other than that, thanks for hanging around. Good luck on your first assignment. I'll post this ASAP so you guys can rewatch it before your assignment comes out tonight. I think it's coming out at 7 p.m. today. So you might want to go back and check this stuff out before you start your assignment, but I'll try to be diligent about posting it so you can have a good luck. If you have any questions, you could, if you're really desperate, you could email me, but otherwise put it in the discussion board. But if you really feel desperate, you can email me. If you really can't get the answer to the question answered. Cool. Have a good afternoon, everyone. Well, it's still morning, so I just say have a good morning.